Hello and welcome in video lecture series Demystifying Blockchain. In this video, we will talk about Bitcoin block. In particular, we will look at what goes into Bitcoin blocks. In previous videos, we have seen what goes into Bitcoin transaction. There we have seen this is basically set of inputs and set of outputs that we create. Okay. Now, if we look at Bitcoin block data structure, we have the following information, right? We have block size, right? 4 bytes are being used to represent block size. So this represents what is the size of the block. This depends upon the number of transactions and the size of each transaction, right? Then we have block header. This contains metadata of block, right? So this has the data about block. How many, like what is inside block, what information it has about transactions that are inside the block, about the consensus proof of work, right? So all those informations are placed in block header. We will see that in next slide. Then we have transaction counter. This determines the number of transactions in the block, and finally the actual transactions inside the block. So this maximum size goes into the transactions, because basically what block does, it just collects the transactions, places them in a block, and then block is connected to the previous blocks. So basically this is the way where we record transactions permanently in a blockchain, right? So overall we have seen the block structure. Now we will take all those fields one by one. Most important field is block header. We will look at what goes into the block header, right? Now if we look at the data structure, right, what is inside the block header, we have following information, and all those fields are very important to understand in order to understand Bitcoin protocol completely. So first thing is version. This is just like a software version. This indicates what version you are in. Basically when we do some upgrades to the network or a protocol, we change the version. Just like in the software, if you have latest version of any particular software, it has more features or it has some bug fixes and all that, right? So the first information is in the field version. It is 4 bytes, right? Then we have another field that is previous block hash. This represents the previous block hash, right? If we look at currently, we are current at a stage where we have block number 10, and this will include the hash of block number 9, right? So this is 32 bytes. Why? Because we use SHA-256 hash algorithm, right? So this produces 256 bits, that is 32 bytes. Then we have Merkle root. These two fields, like this Merkle root, is very, very important. This is again the hash, right? This is again the hash of what? It's hash of a tree, root of that tree, called as Merkle tree, right? That is basically a data structure that helps us to take the hash of all the transactions within the block very effectively, right? And it is very efficient in other ways, just like in verifying whether a particular transaction is inside the block or not. We will look into this in a separate video, right? Then we have timestamp. This is like Unix epoch time, right? That is basically a number that represents the current time. So this time is usually based upon the miner's activity. If miner is trying to participate in the proof of work, at what time he starts to look into the solution for that difficult proof of work puzzle, that will be that timestamp, right? So timestamp at which the block creation starts from the miner's side. If he is successful, then this will be recorded into the blockchain, and we have this timestamp. Then this is a difficulty target. This is how difficult it is to mine a block, right? So this difficulty is represented by this difficulty target. This is related to the proof of work algorithm. There are other things that are related to it, like we have bits difficulty target, right, and target hash. We will see how they are related to each other, and we will have a dedicated video for this as well. Then we have nonce. This is not more than once. This is again related to proof of work. This is the variable part of this block header, right? So when miner starts to take part in solving that proof of work challenge, then this nonce is being constantly changed. Whenever they hit that, like the hash of the block goes less than the target hash, this nonce is considered as that nonce. When the hash of the block is less than the target hash, that is recorded inside this block header. Now if you look, when we try to hash a block, basically we are trying to hash this block header, right? So for miner, version is static because the node will automatically see this which version they are in currently, right? Node is compatible and they select this version. They will take the previous block hash from the blockchain itself, looking at its previous block, and take the previous block hash. Merkle root they will calculate because they have all the transactions they want to put into the block, and they will use that data structure Merkle tree and calculate this Merkle root. Timestamp is actually the current time at the Unix epoch time. So this is basically a number, right, representing the current time. This is also available for the miner. And target is again based upon the network protocol. So difficulty, how difficult it is to mine this block, where they try to find a solution for that proof of work. Now the only part that is variable is the nonce, right? They start looking at the particular nonce value with which they will be able to find the solution, and then nonce will be recorded inside this. Once this nonce is recorded, then they have a new block with all sort of information in the block header, and with this they will get the current block hash and the block number, right? So that is block header is very important aspect. Block header is very important part of overall creation of blockchain in Bitcoin, right? In any blockchain, not specifically in Bitcoin, but here we talk about Bitcoin specifically, right? Now if we see how blocks are created and how they are linked to each other and how finally we have a blockchain, if you look at this is the header that we have talked, right? It has specific information, it has previous block hash, timestamp, difficulty, Merkle root, all sort of things. When suppose this is the first block, this is second block, and this is third block, just for the sake of simplicity, when first block is there, previous block, it will refer to its previous block. Like maybe there is another block that is 0th block, so the hash of the 0th block will be previous hash here. Okay, if we take like this, now we have second block, the previous hash will be the hash of block 1. If you look at what is the hash of block 1, that is this, and we go into the block number 2 and look at previous block hash, that will be exactly same, because if you look at here we have 2249 and same is here 2249. Now after finding this block, there will be hash of this block as well, that is here, and that would be recorded in the next block. That's why we say, if we say blockchain is a chain of blocks where each block is connected to its previous block with a special link called as hash pointer, right? So if we look at previous block hash 0569, and see this is the hash of this block too, 0569. So this way blocks are connected to each other, and look how beautifully they are connected. If you try to modify anything inside any particular block, whole the chain will be broken, so you won't be able to have a consistent view of that blockchain, and will be able to know that something wrong has happened, right? So this is about how blocks are connected and what goes into the block. So specifically we have seen block header, what are different fields in a block header. Now in next video we will see about Merkle root, how this root represents all the transactions that are recorded in the particular block, right? Because we deal with the blocks now. Block header has a Merkle root that determines, and that is a representation of all the transactions inside that block. After looking at the Merkle root, we will definitely go into proof of work and we will look at this nonce. Then we have separate video for difficulty target, how this difficulty target is represented in the real Bitcoin block header, right? So this is it for the video. Now if you like the content of the videos, do hit the like button of the video and do subscribe the channel